It's always great to be at exhibitions because you meet a lot of people. And one of the guys that just came over to me and say hello is my good friend Tri.
Hi.
Good to see you, Tri.
Very good to see you. That's fantastic.
Last time I met you, you gave me a tremendous headache.
No, did I?
Not really, but it was at the Seiko Open House in Frankfurt.
That's right.
And it was just amazing because what you work with is so much in the motor engine of Inkjet, right?
That is correct. So what we do is basically we are characterizing inkjet ink, and especially in the condition of the printhead itself. And that is one of the key missing parameters whether people make ink formulations or whether in terms of printhead specification itself. What is missing is the dynamic property of the ink, which people tend to neglect, and that's where we see the difference in the batch or formulation or jetting.
You say neglect, so you say that still, even that you are in the market and with the knowledge that you bring to the market, some OEMs are still neglecting the what's it called, the parameters of
the dynamic. Yes, I think it is still people haven't appreciated the importance of it, because what people don't realize is inkjet operates in a completely different time scale and the geometry, right? So we're operating the microsecond time scale and the micrometer geometry. And people still, all the concept of metrology tools, the characterized tools are developed in a milliseconds or second time scale, and we're still stuck in that, right? Even now, if you look at the printhead, if you look at any printhead, the specification comes with the viscosity in a certain shear rates and all that. I haven't talked, but their time scale is completely different, right? And that's the difference, missing gap in it.
And I would recommend people to go and see the interview we did with you, because you also showed, and I think we mentioned that in the film we did from you in Frankfurt, was that you can see actually the drop and how it forms based on the resonance because we spoke about the little music thing we had together, right?
I think
with the resonance of.
That's right. Because I think you came from the guitar and all that. You talk about the resonance, and Inkjet is completely acoustic device, right? It's the Helmholtz resonance of the fluid of the system itself really matters. And then again, if you put anything in the fluid, like tomorrow I'm talking about aqueous printed and aqueous ink, right? Suddenly, as soon as you put water in it, it's completely different. It changes the resonance, it changes the speed of sound, everything. And it has a very different effect in terms of the printed reliability and it's also in terms of jetting, right? And the question is, do you have the tools to characterize in the time scale you are looking at, jetting it?
Yeah. And you also said to me last time that actually water is not the best carrier for the pigments, right?
Not at all, right? Water is the most difficult carrier from all aspects of it. From this, if you look at it from the acoustic, the speed of sound of the water is very different. If you look at it from the molecule size, right, the water is the smallest molecule as a carrier, right? So it's got the diffusion and the effective rectified diffusion that makes the printhead more susceptible to prone to failures, right? And in terms of surface tension, water has a completely different surface tension than any other fluid, so that has a different pinching behavior of the droplet. So water is complete. And people think water is a fast drying. Water is a slow drying solvent, right? Again, the drying becomes another challenge.
And that is actually one of the things that I think has changed quite a lot since we met each other last time, because if you look at some of the print machines now in the market, much faster, much higher densities, and much bigger surfaces, because now we're really taking over the commercial print market. From an engineering perspective, how big a challenge do you think it has been for these manufacturers?
I think from the scaling up, I think it's not a challenge because the fundamental physics is still the same, right? But now the problem is in terms of getting the reliability right? When you scale up, if only one single nozzle it affects the whole system. So it's now about getting the reliability right. So then now the controlling of the fluid property or the dynamic property again becomes more critical, because all you would need is one or two nozzles to fail in the whole system and everything stops.
And it's funny that you mentioned that, because we were actually in Dayton, Ohio, just a few weeks ago, seeing the new Kodak 520. And then they have the continuous inkjet instead of the drop on demand. Does that answer some of the challenges that you talk about?
Yeah, the continuous inkjet works on a different. So continuous Kodak is quite good at that. So because they had the stream jet also in the past. The continuous inkjet works on a principle that you have continuous jetting, and they have
it's always wet. Basically.
Always wet, and they have a different high frequency to pinch it. So they have a different pumping mechanism to jet, and only in the past, even now the CIJ has the problem is the resolution, right? But with the Kodak's technology and all that, they can get the resolution. Why? Because they can pinch it much nicer, better way, and that gives you the higher frequency and the resolution, right? So that's a challenge you have. So again, coming back, drop in demand is also moving in that category, right? Drop in demand has a resolution but didn't have a speed, but now they're going to the frequency side. CIJ used to have the speed, frequency, but didn't have the resolution, right? So it's a meeting of that two part, and Kodak seems to have done reasonably good. They have the history of doing it. Good. So.
I was just thinking with Trijet and your company and basically the consultancy that you do for the industry, I think that still, I mean, if you look at the speed of the machines today, they're getting closer and closer to offset machines, of course, right? But I was just thinking, do you see the biggest challenges when it comes to being even faster? Is that in the understanding of the what you're talking about, the
fluid rheology becomes a key part, because once you
and getting away the water,
getting away the water, but also getting away the pinch of drop off, right? As you go increase higher in speed, you end up getting more satellite and misting and all that. And how do you control that, right? You cannot change the fluid, so only I can change the fluid dynamic property so that it pinches at the right condition and you don't get the satellite misting.
Is that something that you have solutions on how to do? Or?
We do quite a lot of clients. We're pushing, even if you look at from traditional inkjet, coming from 6 kilohertz to 30, 40 kilohertz, this has been pushing the boundary, right? The fluid is the same family of the fluid. Just by subtly understanding the dynamic property, we can start tuning it and get the reliability you wanted. So when client asks me, can you give me a print frequency, right? I say, I can give you, but I may not be able to give you the reliability, right? So if you want the reliability, so it jets every time the same, then you really have to fine tune these subtle properties that we talk about, this dynamic complex.
So with what you say now, does that mean that from a physical perspective, I mean like science physical perspective, is there like limitations when you use water-based carrier for pigments? Does that mean that you have a physical boundary for how fast you can do it, basically?
There is always a limitation depending on the fluid choice you have it. So same thing, if you think about the UV ink, there's always a solvent ink will never match up with the UV ink in terms of the print frequency and all that, because the fluid itself is different. And water also would have its own limitations on that because it's got the different dynamics of it, which you cannot change it, right? I can just change the in between the dynamics, but what it is, surfactant-free condition is it is. So there will be a limitation between the fluid family itself, but you can push the boundary, right?
Fantastic. I think that's what printers want to hear, right?
Yeah, that is correct, because that's what we're doing it, right? We're pushing the boundary from the printed design aspects of it, and there's also fluid aspects of it, and the third aspect is the waveform, right? How you drive that. So there's the three combinations will decide how far you can push the boundary of it, but each printed would have its own limitations.
Fantastic. Thank you very much.
Thank you very much. It's nice to see you all the time.
Good to see you.
Thank you very much.